Now we'll talk about adding and subtracting radical expressions. And adding and subtracting radicals is a lot like adding and subtracting variables. And we follow the rules of algebra that you should consider to be very ordinary by now. Let's take a look at this. What if we had 2 times the square root of 3 plus 5 times the square root of 3? This is very similar to adding expressions with variables. This would be very similar, for example, to saying 2x plus 5x, or very similar to saying 2 apples plus 5 apples, like that. And this should be pretty clear to you. 2 apples plus 5 apples is 7 apples. 2x plus 5x is 7x. In the same way, 2 root 3 plus 5 root 3 is 7 root 3. We can add these because we can think of these as like terms. And specifically, we would say like radicals. They're both square roots of 3. 2 times the square root of 3 plus 5 times the square root of 3 has to be 7 times the square root of 3. If they're not like radicals, we can't combine them in that way. If we had 2 root 5 plus 8 root 3, for example, that'd be like adding 2 apples plus 8 oranges. You can't combine the things that aren't like terms. Or that'd be like adding variables, 2a plus 8b. We can't combine them if they're not the same type of thing. So that's the main idea. When you're adding radicals, combine the like radicals when you can, but only combine the like radicals. Now sometimes you end up with radicals that don't seem to be like radicals, but they end up being able to be combined anyway. Watch this. 2 root 3 plus 4 times the square root of 12. Now the thing here is these don't look to be the same, the square root of 3 and the square root of 12, but the square root of 12 is not in a simplified form. Let's simplify that. I'm going to rewrite the whole problem. 2 root 3 plus 4 times the square root of 4 times 3. All I've done is change my 12 to a 4 times 3. I've factored it, and I know there's a perfect square factor. And this 4 pops out of there and becomes a 2. And so I end up with 2 times the square root of 3 over there, plus, and here I have a 2 times 4, plus 8 times the square root, and look at that, the square root of 3. So now I have like radicals, 2 root 3 plus 8 root 3, and those combine to give me 10 times the square root of 3. So rewriting all of the radicals in simplest form can sometimes result in radicals that can be combined. And you should be rewriting your radicals in simplest form anyway. When you see something like this, you should take it through these steps, at least mentally, and get it down to a radical that doesn't have any perfect square factors. And when you do that, then you can see all the ones that can be combined and combine them. And here's an example where we can do that. The square root of 54 can be rewritten as the square root of 9 times 6. The square root of 36 here can just be rewritten as 6. And then the square root of 24 can be rewritten as the square root of 4 times 6. And then we see some things happen. This 9 here becomes a 3 outside of the radical, and the 4 here becomes a 2 outside of the radical. So we end up with 3 times the square root of 6 plus, and I have a mistake right there. That should not be a 3. That should be a 6. That's the square root of 36. Should become a 6 right there. And that 6 carries through down here into this step. And then over here we have a 2 times the square root of 6. So our 6 is all by itself, but these other two terms are both like radicals, so they can be combined. The 3 root 6 and the 2 root 6 will combine to give me a 5 root 6. So I end up with 6, that's this 6 right here, plus 5 root 6, and that's my answer. Let me write that a little more neatly. 6 plus 5 root 6. Okay, this next example is pretty tricky. It simplifies nicely, but it takes a few steps to get there. I have the square root of 2 minus the square root of 1/2. And we're asked to simplify this. So we need to rewrite all the radicals in simplest form and see if anything can be combined. Well, this one is not in simplest form. We have a fraction under the radical, which we're not supposed to have. So let's take care of that. I'm going to extend this and multiply by 2 over 2. And that's going to become a 2 in the denominator right there, because I have a square root of 4 in the denominator. So now let's rewrite the whole expression. I have this first square root of 2 minus, and what I have now is the square root of 2 over the square root of 4. And I got that just by multiplying the 1 and the 2 to give me that 2, and the 2 and the 2 to give me that 4. And then the square root of 4 simplifies. So I end up with the square root of 2 minus the square root of 2 over 2. And it turns out that these two can be combined. I'm going to take this first term here, square root of 2, and I'm going to write it like this. 2 root 2 over 2. You could see that I could cancel the 2's there, but I'm not trying to do that now. I'm trying to get both of these written with the same denominator. So let's leave this second term the same. So I have minus square root of 2 over 2. This, what I've written here, is exactly the same as what I've had before. I just added those 2's right there so that these two expressions would have the same denominator. And now I can combine them. This is 2 root 2 minus the square root of 2 over 2. And then these are like radicals up here. Think of this as 2 root 2 minus 1 root 2 right there. I'm going to rewrite that with the 1. You can think of that as 1 times the square root of 2. And that's just thought of that way. Even if you don't write that 1, it's just easier to think of it that way. I have 2 root 2 minus 1 root 2 gives me 1 root 2. So I end up with the square root of 2 over 2. That's my answer. And that really is in simplest form. We can't get it any simpler than that. And we'll come back in the next video and continue to work through some more examples of combining radicals with adding and subtracting them.